It has been a hot minute since I've seen one of these in my shop. This is a Tinman box. He was an okay dude. I got nothing bad to say about him at all. He's not in business anymore. Shit happened in life and whatnot, but the vinyl wrap that's on this amplifier is really quite epic. It's a Harley Quinn theme. I mean, it is just a beautiful wrap they put on this amp. I mean, he had the most professional stickers for everything. Now, the other side of this amp might show some body bits of Harley Quinn that would promptly, immediately, and swiftly get this video demonetized. So I had to add some, well, let's just say tape, because even on the graphic, they even put Bush. I was so proud of them, man. The wrap on this thing is epic and in first order. That's all I'm going to say about that. So this is RO number 39 and RO number 40. And what do I mean by that is, well, apparently an unknown to RO number 2. There's 3 amps in the same box. This is an unknown. He doesn't know who it's built by. 2 2290s driving 4 2879s. And he wants a master class built 4-pill built out of this. I said, I can do that. So the only thing he wants to spare out of this old Dave made cabinet. Somebody took a Dave made cabinet and they polished it and put it back together. The only thing he wants out of this Dave made cabinet is the transistors. I'm assuming it's got Toshibas. I don't know yet. I don't know. This is an old school Palomar 150A. This one here. And I got to call and get clarification and see what he wants me to do with that. But on that note, okay. On that note, let's take the tin off this one and take the lid off this one, and we will get this done. Okay, so the customer's made it very clear. The only reason he bought this amplifier, which we don't know who made this, it's obviously a Dave made cabinet, but he wants these pretty transistors out of here. So this step here is, let's take some of this apart, save as much of this as possible, because I have plans for this in the future, because I think this is mine. I'm not too sure, but I mean, if he wants it back, great. We'll make it work for him. But let's get these transistors out. Let's get them over here and let's test them. What do you think? So let's check the gains out on these Toshibas here. Let's start with our 2 2290 drivers. These things are so pretty and so clean. I thought maybe these are fakes for a second, but the feet are real and it checks. So let's see, what do we got here? 24, perfectly good transistor. What we got here? $23. Looks good to me. Let's go look at the Toshibas, the 2879s. And by the way, this is held together with that silicone grease, that thermal grease. 23. All right, so we're gonna be 23 across the board. No jaw-dropping transistor numbers here today. 23. Yep. This is good. $24. All right. Do. 424. All right. Well, we've got a total of 6 good transistors here. I've got one very empty cabinet that needs occupying. Let's get to it. So here we are a few days later. You know, I would have done a huge melodramatic, artsy video shoot, but you guys have already seen me do this about 1,000 times on video. So we took his two 2290s, his four 2879s, and we built him this. Masterclass build, style, quality, biased for sideband, set up 2x4. So our driver section, if you notice, there's a lot of shit stuffed in this one little space. Like, it's tight. She's a tight girl. But we spit on it, and 5 fingers later, and everybody's happy. It slid right in the hole. So, I ended up having to make a custom output transformer. My fans, my friends, my associates down here on Patreon, the ones that are allowing us to watch YouTube videos without ads, by the way, they're the main reason that there's not an ad every 5 minutes that's a minute long. It's because of the support of these guys right here. One of my Patreons did notice, he goes, there's no capacitors on the output tune of the I was like, yep, you got it. You got it. I don't know quite how this is going to tune out yet because I built a custom transformer. If you notice, just count the cores. 1, 2, 3, 4, 5 versus 1, 2, 3, 4. Means the capacitance here is going to be higher than what we would normally put for this size transformer in this position. We got to make the part think that the transformer is longer, and we compensate for that with capacitance. The other challenge I had is I bought a whole bunch of this Teflon 13 gauge wire, and it's labeled 13 gauge, but it's more like 12. So we're going to run this. I don't think that this is going to affect anything. So the size of the wire in the core of the transformer, I might have to adjust the output tune just a little bit to compensate for this, but it'll be fine. I just think it's neat. I ended up buying from one company. I bought some 12 gauge, and then I noticed they had some 13 gauge on sale, so I bought a whole bunch of this 13 gauge, and I wanted to try it real quick. So we're going to give this a whirl. If not, I can rip these windings out. We'll change everything, but I don't think we're going to have a problem. Just a lot of stuff going on in a small little footprint. Got our bias and our transmit all set up. So all I've got to do now is drop this into my prepped cabinet. Just slide this in, hook up the relays, drop some power positive wires on it, put a key in circuit in it, hook up all the switches on the front. The customer does want a variable, which I'm not a fan of building with the variable. This is you put more than like a 148, you know, like a 20 watt, 30 watt radio through this amp, this variable will burn up. It'll just burn up. Done. End of conversation. Burned up. So we have to keep that in mind. This guy says he's going to run a 148 something 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 or other, and good. Low drive. You wouldn't want to use like a 99 V2 or something like that that puts out 45 watts because it's going to overdrive the 2-pill section here. Now, 2 driving 4 is an awful lot of drive for the 4-pill section. It's technically too much. So that's why these guys, they'll put a voltage divider like what I've done here with these 2 5-watt resistors. They'll put a voltage divider between the 2-pill section and the 4-pill section, and then we put yet another voltage divider. We'll employ it off of the variable to try and knock the input drive, and the output drive, we're going to cut it down a little bit. We're going to snub it just a little bit to try and keep it so that we don't overdrive the 4-pill section on this amp too awfully bad. So this has got to get done today, and I've got to get onto this guy's 8-pill The Tinman built A-pill, I got to go through it. This has got to get done today. So here it is now. I've spent last 3.5 hours on the phone. It's already 10:30 in the morning. This has got to go in here. I've got a bunch of shipping I got to get done today, but this is where we're at. We took his incredibly expensive parts. We took them out of that other cabinet, and then we're building him a whole brand new amp to go around those expensive parts. And this is where we stand. Even did all the trick stuff, like drilled through the heatsink for the bias control wire, so when we slide this in, we don't ever have to worry about it rubbing against the edge of the cabinet kind of thing. Food for thought. All right, we'll be back. Okay, so amp's all cased up. And it's kind of taking a guess on the output capacitance and a guess on the input capacitance because of this transformer. Nailed it. That's all I got to say. I'm going to bust this one little portion of this segment out all by itself as a teaching moment, and I'm probably going to put this in its own separate YouTube video. So let's go ahead and have this conversation here really quickly. First off, let me show you drive coming from the radio. So what we've got going on here is a 1,000 watt slug in peak, 1,000 in average, and a 5 watt slug in reverse back from the Bird 10,000 watt dummy load. We're using the Bench 2950. As we can see, we're dead keying just a little over a watt, maybe a watt and a quarter. Hello, 1, 2, and we're swinging up to about 35 watts. Okay, so now we have an idea of drive. Now, I hate to say it, but my darn amp meter over here is gone berserk. RF finally got into it after 7 years or whatever. I've got that exact same metering circuit coming. It's in the mail. It should be here any day. So we're going to ignore that and we're going to look at this voltmeter. Now the question that was posed to me earlier today, okay, was this simple. I've got, and he rattled off the radio, I don't remember what it was, a Magnum something or other. And I've got it turned way down. I said, okay. He goes, it's doing about 35, 40 watts. I said, all right. And he goes, I've got that going into an old X-Force 2x4. I said, okay. He goes, I got this in my truck, and I can't seem to get it to see more than about 600 watts. And I said, oh, all right. He goes, does that sound right to you? And I said, well, maybe. I said, what's the charge voltage on your truck? And it's a 2000 and whatever it was Toyota. And he goes, 13.8. And I went, yeah, that sounds about right. He goes, what? And I said, about 600-700 watts out of a 2x4 is 13.8 charge voltage. Makes sense. He says to me, okay, but I bought the amplifier from Chuck Banner. Chuck's a friend of mine. Chuck's a good dude. He's straightforward. He buys and sells stuff like it's free, right? He gets a kick out of it, buys it someplace, marks it up a little bit, resells it. It's called, you know, American economics. It's just the way things work. So what we have here is an explanation. I explained this guy on the phone to him. I said, okay, so you got to think in your vehicle. You have all these different things of loss. And he goes, well, I've got a ground wire going from the alternator down to the frame. Then I got 4-gauge wire going from the battery to da-da-da-da-da-da-da. And I'm like, cool. I said, but your only form of measurement's what? And he goes, my dash voltmeter. I said, but what's taking place inside the amplifier? He goes, what do you mean? I said, well, why do you think I use such big wire? Like, this is 4-gauge. In theory, by the book, it's too big. It's not needed. It's overkill. It's not necessary. Ah, but it is. I feel. See, I'm in charge of what I do here. I get to do whatever I want, not, well, you know, they say technically that this is not, da-da-da-da. Great, got it, good. Shut the fuck up, don't care. Me personally, would rather have 2 pieces of 4-gauge going in here versus, you know, a single piece of 8. Because in theory, a single piece of 8 can easily handle everything that's going on here. So, as you can see, I've got 15.32 volts on the distribution rail inside the amp. So we've got 4 gauge coming in right to the distribution bus. The 4 gauge is having to carry the current for these 4 transistors, and then it goes through this positive rail here, this copper bus, over to the output transformer of the 2-pil driver section. So we know 4 transistors pulls 100 amps, and then the 2-pil section itself is going to pull another 25, 28 amps, depending on how you calculate your loss and getting the current over there. So we're looking at about 125 amps, 130 amps max worth of draw. We've got oversized wire going in, 1,000+ amp power supply, not the little 90 or 120 amp supply that would be coming off of your alternator, your charge system on your stock vehicle. 1,000 amp plus, fed with 4 gauge cable, hooked up to a giant distribution network attached to 6 frickin' batteries, 2 super caps, and 1 lithium thing. There's, on the other side of these terminals, like find some wood, touch wood, thank God I've never had anything metal fall on these 2 tabs, because it would just disappear in a giant 12-volt arc of nastiness, right? There's a lot of current on the other end of these wires. Now we all know that current stays consistent in the circuit. The thing that we're trying to keep up is the voltage, right? So watch this box run. We're just going to watch this run for a second. Here's our output power. Remember, 1,000 peak to average 5 watt. Oh, I'm going to turn that 5 watt slug around, or I'm going to destroy it. Okay. So you got the radio dead key in, 1 watt. Like 1 1/4. At 1 1/4 going in, over 1,000 watts, no problem. 450 to 500 bird. 1 2 1 2. So let's go over here and look at the voltmeter. 1 2. 14.7 from 15.3. So now what we can calculate out in our brains is if your charge system and this is going over 4 foot of wire, we're having that much voltage drop over 4 feet of wire, and that's to the inside of the amp. Now, as I was explaining to him, the voltmeter on most modern vehicles isn't actually physically attached to the charge system on the vehicle. It is a reading that is spit out by the computer to the display. So are we really at 13.8? Are we at 13.5? And I said, well, how many feet of wire do you got going from your battery back to the amplifier? Well, we all know that that's going to be about 12 to 14 feet. 3 to 4 times this length. Let's turn the power supply off. And let's go ahead and let's let the voltage kind of chill out here for a second. Okay, so now we're down below 13 volts. At 1 2. So now we're down to 17 volts, or 700 watts. So we're at 13, let's say he's got 13.8 going in. At 1 2 1 2. He's pulling to about 12.5, 12.6 volts in the amp. And it's probably worse than that with all the length of wire. Now, let's say he decides to run it on sideband. Exact same amount of drive, or just simply now running on sideband. At 1 2 1 2 1 2. Now we're around 650 watts, 700 watts here. But look at our voltage drop. At 1 2 1 2. We're down below 12. My power supply will not let me adjust anything lower than 14 volts. So if I reach down here and I turn this on, let's see if the power supply is going to be kind to us. I think it's going to make me sit at about 14.1. 14.1. He's at 13.8. So 0.3 of a volt off from each other. Sideband operation. Hello, 1, 2, 1, 2, 1, 2. I'm getting 800 watts, which is 200 more watts than what he's getting. That's from the bigger cable. I guarantee you his X-Force doesn't have 4-gauge wire coming out of the back of it. Let's go back to AM. Hello, 1, 2. We're not pulling as much current now into the system, and our voltage is able to stay higher. Look at our peak power output. Hello, about 900 watts is what we're getting out of this thing. And look at our voltage drop. Hello, 1, 1, 1, 1, 1. Versus sideband operation, where we're going to pull vastly more current. Hello, 1, 2, 1, 2, 1, 2. There's our output power. Hello, 1, 2, 1, 2. The reason I wanted to bust this out on its own is because this gentleman was absolutely perplexed. He's like, I don't understand why my amp won't do more than 600 watts. What's wrong with the box? And I told him, nothing. Nothing. There's nothing wrong with your amp. What you need to do is find somebody that can doobly-doo, like an EFI Live or, you know, HP tuners or whatever, that can go in and let you change the charge map on the truck. I said, when you first start your truck in the morning and it's cold, so what's your charger do? He goes, oh, it goes to 14.7. God, it'd be so nice if it'd stay up there. It can. It's a setting in the computer. Okay, the computer is designed to try and optimize the life of your battery and blah, blah, blah. If you can go in and get that changed and get your charge up to 14.7, I said, your 2x4 is going to come way up in power. We just proved it right here on video. That's the way things work in the Wild Wild West. Gentlemen, thanks for watching. I busted this out of another YouTube video. I'm going to go on and continue finishing this video for this amp. Thanks for tuning in and following along. I appreciate the thumbs up. Hopefully you guys learned a little bit. We went on to have the discussion on the phone with how much is it really going to help him to get that extra 400 watts out of the box by getting his voltage up. It's not going to help him that much, because we all know that, you know, for you to make a dB gain in somebody's radio, you've almost got to go up 3 times in power. That's if you're transmitting on an omnidirectional antenna. We just sat down and we talked about it, and I said, you know, you can be happy with what you got, or you can go down the rabbit hole and change the computer, and then you're going to need to put bigger wire and that kind of thing, and you'll get more power out of the amp. You will. So ultimately the decision lies with him. But thank you, gentlemen, for tuning in, following along. This is just one of the many free-form things that I do. I put this kind of content on Patreon all the time. You might want to come along and try and check us out on Patreon. On that note, gentlemen, I appreciate you. I'll see you. Click, click. Okay, now that I'm done recording that, this was just a quick experiment in me being able to show that voltage makes a big difference in what the amplifier does. And there's a reason that we want to use big wire, because we want to try and keep the voltage up. The amperage stays consistent in the circuit. As the voltage drops, amperage increases, blah, blah, blah. But our number of watts stays consistent, so the amperage is uniformal. It's just going to stay present in the circuit. We want to try and keep the voltage up, and how we do that is with bigger power lead. Okay? So, you know, I put 4 gauge coming out of the amp. Really, in an ideal world, you know, you'd want to run 4 from the battery, if not bigger, preferably 1/0 to a distribution block, and then 4 gauge to this thing. That's in an ideal world. Most people aren't going to spend that kind of money, but it is what it is. Okay, back to the salesman side of me, where I'm showing the customer what he got. I've been having a lot of fun with copper. I always have. Now, we know that this has only got to carry about 25 or 30 amps. I went ahead and used a couple thousandths piece thick of copper. I put some heat shrink over it so I'd never have to worry about it making contact with the board. I wanted to make sure that if we ever needed to remove the screw or put the screw in, it'd be insulated. And so I put some 600 volt marine grade with epoxy on the inside of it, heat activated glue. over the top of that. I just threw the kitchen sink at it for you, bud. I really did. Now, what I didn't show in the last little segment, because it wasn't overly relevant, is we need to come up here and we need to look at these meters as well. We're going to look at this one. Where's my finger? This one here specifically. Amplifier off. What I'm going to demonstrate now is the RF's ability to come from the radio, through the amplifier, through the test leads, through all the different watt meters, and down to the 10,000 watt dummy load. 1, 1, 1, 1, 1, 1, 1, 1, 1. It's perfectly flat. That's what we want. Because remember, it affects the RF both ways in the amp. Or both ways. That's from the antenna into the radio, and from the radio to the antenna, right? So if this portion, this pass-through isn't low, it's going to cut down your receive a little bit. It will. That's why I show that in every video. All right, let's take a minute. Let's take a look at the input schwirr. That's the amplifier keyed. Hello, 1 1 1 1 1 1 1 1 1 1 1 1 1. All right. That's the magic numbers. The magic numbers are perfectly flat. And we got there with using an 18-foot piece of coax going into the amp. So from the bird meter down to here is 18 feet. So you can do like 6 1/4 and then 18 feet, which is called a non-reactive piece of coax length. It's different from the resonant length of coax, right? Which is something that you'd use between the amplifier and the antenna, not the jumper for your amp, which I hear people get this backwards all the time. I've done many a video, many a Facebook live feed about it. I'm tired of talking about it because everybody has their own opinion, and I just simply go, whatever. Okay, so like I showed in the previous segment, hello, 1 2. This thing's disappearing off the scale. Remember how I talked a couple segments ago about the different voltage dividers that we have in here, reducing the signal that's coming in? I have a 30 watt radio that's coming in through the relay, going through this little piece of 316 coax. It's showing up over here again on the board. It's going through a voltage divider, which is this variable potentiometer. On the other side of the variable potentiometer, we have a 100 ohm 5 watt resistor going to ground. And that's to give ourselves a little bit of a load for when we have the variable turned down. Down is clockwise, up is clockwise. So up that direction, down that direction. I think that's been a universal standard since before Spinal Tap. Just saying, this thing definitely goes to 11. Even with this 10 watts worth of voltage division going on here, going into the 4-pill final section, we end up having this as our end result. Now this watt meter here on the far right is now in 2x. Those of you that have listened to many of my YouTube lectures before, when the meter goes all the way over here to 100, that's 2,000 watts. So now 1,000 watts is right there, that big hash mark between the 40 and the 60 or the 20 and the 30. That's 1,000 watts. Every major integer of marker left going that direction on the scale is another 200 watts. So how this works out: 1,000 watts, 1,200, 14, 16, 18, 2,000. Pretty simple. Easily over, hello, about 1,300 watts. That's with only 30 watts of drive, but then again, like we were talking about in the previous segment, that's with the power supply turned up to 15 volts. What's the amplifier actually operating on? Hello, 14.9, or on sideband, the amplifier is actually operating on hello, 1 1 1 1, hello, 14.5. And we always take the lowest number. And that's because of line loss. So when people say to me, well, you're being abusive because you're running the voltage so high. Am I really? Because inside the amplifier, it's only seeing about 14.5 volts. Maybe I've measured something or done something that you haven't thought of. Fuck if I know. Fuck if I know. Let's turn this down a little bit. Let's give some real world numbers. Turn this down. Come on down, big girl. Come on down, on down, on down, on down. Hello, 1 1 1 1 1 1 1 1 1 1 1 1 1 1. Okay, power supply stabilized out. We'll shoot for about 14.8, 14.7. What's the amp going to do? Hello, 1 1 1 1. Let's go over here and take a look. Hello, 1 1 1 1. About 1200 watts again. 1100 watts. On 14.8, which will drop us to a magic number of, survey says, 14.4. No matter how you go about cutting it, you can feed into the amplifier 15 volts. On the inside, it's going to see 14. You can put 14 and a half on it, you're going to see 13.9. It is what it is. There's line loss that's involved. This thing runs perfect, like a Swiss watch. Now the other box, the Dave made repolished cabinet, I have no idea what that piece of shit did. Don't care. All I know is what I created this guy going out the door. So let's go down the checklist. Things I have left to finish. I've got to put a fan on this thing. Got to put a fan guard on it, which I'll do here just momentarily. I got to put some vinyl on it, put a sticker on the front, some more labels on it. Shoot a little bit of clear on this to make sure it stays clean and pretty like this forever. And let's see. Oh yeah, I'm done. So when we come back, I'll show you the cabinet completed, the lid on it, and all that kind of stuff. But for the most part, we're done with this, and we're very quickly going to go translate over to the Tinman box with the titties on it. So I go in, I get my wife. I said, you got to come out and see what I'm working on now. So she comes out and she goes, what's up? I said, well, I got to tell you, honey, there's pornography in our home. She goes, oh yeah? What kind of kinky shit are you into? And I'm like, well, it was sent to me, dear, and I don't have any say or control over what gets sent here, as you know, so please don't take it personally. And she's like, show me, what do you got? So I turned the amp around. I had the amp facing away from her. I turned around. She's like, ooh, what's this? And so then what does she do? She immediately walks over with her finger and goes, let me see. And she goes to pull the tape off, and she's like, whoa, it's got nips on it and everything. And I said, yeah. And she goes, wait a minute, they did Bush? And I'm like, yeah. And she peeled the tape away. She goes, holy cow. She goes, this is a really good wrap. I was like, that's right. I said, but the side of it that I like is this side. That's a neat picture. I think that's cool. But it caused, this thing caused a good laugh around our home. My wife and I find many different things very funny. So anyhow, I watched my wife look at some boobies today. It was kind of cute. Anywho, okay, so the problems with the Tinman box. Look, met him, know him, good dude, just couldn't deal with the stress, I think. He had some other stuff going on, and that's the reason he's not in the business anymore. Not going to get into it. It's none of my concern. Let's see. Input reflect is a little bit too high. He sees 3 full, 4 full bars with his striker. The other thing is when he keys down, the fans almost stop. And he's got the good JMC fans on it, but these things are very prone to getting RF in them. So I'm going to take all this apart and fix this up so RF no want to go that way no more. We're going to put the fans on the outside of the cabinet so we can pick up more air velocity. We're going to get rid of these screens. We're going to go to black wire, like regular wire screens like this here. Let's see. I had a whole bunch of these the other day. I might have something like this. We'll go like this. I got more. I'll find more of these. And we'll fix this around so the fans quit. He says as soon as you key down, they just stop, and as soon as you unkey, they go up to max RPM. He does want me to bias this for sideband. It was funny talking with this guy. I've done a lot of business with this dude. Me and him are friends. He's a good guy. I said, do you want me to bias it for sideband? He goes, I feel like I want you to. Okay. All right. He says that, I hate to break it to him, I use inductors like this all the time. This inductor thing is something I do. This capacitor here on the input tune is a little bit too small, in my opinion. Could cause a failure. These capacitors here, we're going to replace them with metal clads. These Chinesium, straight off the boat from China, blue caps. Fuck it, bucket. They got to go. So we're just going to go in here and we're going to touch this up just a little bit. He goes, it makes great power. Box runs really good. He goes, the input tune's a little bit too high for my liking. I said, okay, I can handle that. Fans, bias. And I think I'm going to do bias first. We'll get that nailed down. Then we'll get these caps changed out. And then we'll do a retune on the input. We'll use a capacitance tube. So it's like this. So it can handle a little bit more drive. And maybe if he gets this on his end and it's still not quite just perfectly dialed in for his striker, I can explain to him how to adjust it and make it so it's perfect for him. And then we'll do the fans last. So, biased first. Here we go. Okay, we're going to start tip to butt here. I went and I cut these slots out because all they do is cause drag. They slow the air down as it's coming out of the cabinet. So we're wanting to maximize the amount of airflow we can get out of the cabinet. It's the reason that we're moving fans and stuff. So I went ahead and I hand filed these back. So everything's nice and smooth. There's no sharp, shitty, jagged edges on anything. It all looks pretty. Okay. So now let's go move up here to the inside of the cabinet. You can see that we have our biasing resistors now installed. I was able to sneak in here the relay for the bias. We got rid of these garbage caps. It's amazing to me this amp hasn't failed. That means it hasn't had a lot of talk time on it with those caps in there. We replaced our input tuning capacitor. This is about 50 or 60, it was like 58 picofarad. So I went ahead and I matched that with this tuning tube. Now we know this wire is going to add like another 10 picofarad to it, but I also added a support stand to support the front end of this coil because we don't want to have it moving around. I've seen way too many times in my time of doing this where this is not acceptable. It would be okay if you had like 5 or 10 caps there like X-Force used to do back in the day, but this is much more solid, way more stable. I was able to squeeze all 4 of these in here with the way everything was laid out. I did have to shorten up these flybacks just a little bit, but then put 2 metal clads in here as well, back in here, which is like 3 times the amount of kV insulation that these can handle. So we'll never have to worry about those failing ever again. So we're at the point now where I can key it. The only thing I got left that I need to do as far as cosmetics go to the amplifier is I've got to put a new label on the front, which will take care of that. Of course, that's our power switch, and this will be our sideband switch. Then I redid the fans. So he was telling me that when he'd key down, the fans would stop. And then when he'd unkey, they'd come back, roaring back to life. Started looking at the regulators that were attached to these fans. Technically, these regulators aren't quite big enough to handle the job of keeping the fans running, but there was 9 miles worth of wire wrapped up in this thing. And the way the fans were laid out, there was a giant cluster hump of wire that was all hanging loose right here. And then this positive lead that comes off the on-off switch was long enough that you could lay it in the amp and fold it back over halfway. So between all this extra wire, and then there was on the positive side one single piece, and I think this is type 61 ferrite, but it was like there was a 6 or 7 inches worth of wire before the positive wires went through that. So the whole idea is we want to try and keep RF out of the fans. Now with these JMC fans, they're great. They move a lot of air, they spin really fast, they're awesome. They pull a little bit more current to do that. But we want to keep the positive wire choked off as close to the PCB control board as we can possibly get it. We want to keep our ground wires as short as possible back to the case, and we want to lift them. The stock wire's got like a 1 point whatever ohm resistor. We want to lift the ground up a little bit more, and that helps keep the RF out of the circuitry. The other lifestyle hack that I figured out, is that if we take aluminized tape, like for ducting in a house or for an air conditioning unit, and put 2 layers over the board, this helps the RF kind of get reflected away from the electronics. So in theory, you know, by putting the fans on the outside of the cabinet, we've helped it pick up velocity stack on the inside. So there's more space between the fan and the turbulence of the circuitry. So that'll get us more airflow through the heatsink, right? But then in the same breath, by us putting the shielding on the back of the fan's going to stay turning. Putting the choke right down next to the electronics helps wipe the RF off, which is what's screwing up shoot, brain fart. I just had it just a half a second ago. This is a frequency modulated motor, and it screws up the actual chip that sends the modulated signal to the fan motor, okay? And then we're going to sum the positive wire together, and then by us taking a full foot worth of this wire off the lead, so it's not laying out over all the circuitry, I have a very strong sneaking suspicion that I think that we're going to be able to have fans that stay turning when the amp is on. I hope. Just saying. Okay, we'll come back to that. Next step, got to hook it up. Let's go key it. Let's make sure that our bias circuitry is all set up properly. We'll tie into our bias lines. We'll get it up on class B, pardon me. And then once we do that, of course, then that changes how the whole tune of the amp is going to be. So I'll probably have to end up adjusting this, and we can adjust this, and we'll get it all lined out. So let me get this thing tuned, and when we come back, we'll give you a progress report. Yay. So this took a couple tries to get right. So here's our regular, well, not our regular, but this is the inductor coil that was on or in this amp. So then I went and I built this inductor. You'll see it's got one more turn in it. It was better, but it wasn't right. So now we have this inductor in here with 1, 2, 3, 4, 5 turns on it. 5 and about a quarter turns. So 2, which would have worked out to about 3 turns on one of these, wasn't enough. 4 turns wasn't enough. I wanted 5 and a quarter. And I'm telling you, the difference between here, I need a pointy device. The difference between bringing it over here, the inductor over here, versus the inductor over here, makes a huge difference. Very, very sensitive, and that comes from these 2 capacitors here, by the way. I'm not going to even get started on that. Let's go up here and take a look at what we got as end results. So this is a 5-watt slug in reverse between the Striker 955, and so we're looking at, you have this lower bar that gives you a SWR reading, and then you have the bird meter actually showing you what your reflected watts are. I don't put a lot of stock in the Striker meter because they vary so much from radio to radio, but here's our pass-through tune through the amplifier. Hello, 1 1 1 1 1 1. Okay, nice and low, everything flat. Hello, 1 1 1 1 1 1 1 1 1 1 1. 1 box. 0.2 of 1 watt. Way better place. Way better place than when this thing came in, because we had 2.5 watts of input reflect with this inductor. It just didn't have enough inductor in it, brother. Now, that being said, I did bias it, but still, you were right. It had a 2.5 input SWR. Okay, so now that thing being broken is going to be annoying to me. Actually, just went and looked. I get that thing, I think, tomorrow. So let's go over here. This is so hoopy. Okay, so we're at 14.93 volts on the box. Hello, 1, 2, 1, 2. And this thing is no slouch when it comes to the power. So let's go over here. Hello, 1, 1, 1, 1, 1, 1. 5 watt slogan reverse, 1000 watt in average, 1000 watt in peak. Hello, about 125 watts peak we're putting into it. Hello, hello. Easy 500 bird. Now we'll put this in 2x. If you guys were watching in the previous segment where I was working on the 2x4, you guys know how to read the meter now. Hello, 1, 2, 1, 2, 1, 2. 1600 watts with little to no effort. It's making great power. Box is working real good. Okay, so let's take the 955 out of line. Let's go over here. Let's grab the blue coax, which is the Striker 4. I just had it in my hands, which is the Striker 490. Man, it's been a 12-hour day out here so far. I gotta get this one done. I got more I have to do. So much more I have to do. Okay, 490. Shut the amp off. Let's go in here and show you drive. Hello, 1, 1, 1, 1, 1, 1. About 200 watts peak going in. Hello, 1, 1. Hello, audio. About 1900 watts out. So we're set. This thing is good. I think that all I need to do now is rehook up the 955, because that's what this guy's using to drive it. And let's do the fan test. We will consider it a win if we can key it and the fans stay turning. Because he was telling me the fans completely stop turning. Before we get that far, I want to spray a little bit of paint on the inside of this to keep this from corroding into the future. I want to put some tape on the input tuning tube, so when I put the case back on it, because the nice vinyl that's on the outside of it, I don't want to take any chances of wearing any more holes in the vinyl or the vinyl ripping. So what I need to do is tape this up, then we'll put the lid on and we'll do the fan test. I'm going to call this amp Titties. 2x4, I'm going to call it Beer. So I think I'm going to label this amplifier Titties and Beer. Hello, 1, 1, 1, 1, 1, 1. Fans don't even slow down. I love my job. I remember I had this one amplifier in here. It was like a 24 pill, and it had these JMC giant fans stuck on top of it and the whole 9 yards. And I was trying to jam a metric ton of air through the amp, and had all the fans on the inside. And I'd go to key it up, and it'd wipe all the fans out. It took me a lot of breaking fans to figure out how I could make these JMCs work like this. Hello, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. Don't even slow down. Doesn't even slow down. It's great. Okay. Titties, you're done. This little guy right here is all I've got left for this one customer. And all that is wrong here is he wants to have it put back to stock. What do you mean by that, BBI? What are you talking about? This little Palomar 150A is the last one I got to work on for this guy. It works fine, from what I've been told, but the LEDs on the front of the amp are a little messed up, and he wants me to repair the LEDs. Because he thinks he burned a trace or he's got something soldered that isn't supposed to be soldered. And I said, brother, I got you covered. Titties and beer. Let's see, how's that phrase go? If it's got tits, tires, tubes, or transistors, it's going to give you problems. So tits, the other amp's tires, this would be tubes or transistors. Titties and beer and transistors. Titties and beer and, okay, sorry. So, spent about an hour and a half looking at this thing. The voltage regulator that runs the key up and the bias is blown on this. The keying transistor, I took the keying transistor, the preamp, the secondary voltage regulator keying transistor out. Everything tests good, but there's something that's not right with this box. And I got on the phone with the customer and he says, you know, I got that amp for free. I don't want to spend any more money on it. It's not worth it to me. And I said, okay, I can totally understand and respect that. He goes, but I want the 2 transistors that were out of it, the blue dot MRF 455s. Yeah. So I got in my hand here. And I said, I'll pull those for you. So 100% of the parts are in that amp. This has got a gain of 25 on it. 25. So I went ahead and put the whole amp back together because I had that blown apart in all of its sub pieces. 2, 5. He says, pull the transistors, I want those back. I said, you got it, boss. Not a problem. And this one has a gain of 23. So what I'm going to do, so I'm going to take these 2 transistors, I'm going to slide them into this bag. I'm going to tape this bag to the top of the Eagle. I'm going to put the Eagle back in its little bag, and I'm going to send it back to you. I know you told me to trash it, but I don't need anything out of that amp. Ever. So I'm going to just send it back. Makes me feel better about myself, so just let me live with it like that way. It's all good. Well, gentlemen, here we are at the end of this saga. This trifecta. I appreciate everybody hanging out with me for the last hour. This represents literally multiple days worth of work. And make a big shout out to the Patreons. Thank you guys for letting us be able to be here. All of us. Let us be here and not have to put up with YouTube's ad monetization and having to look at annoying video YouTube ads about diapers and whatever else they try to sell 60 and 70-year-old people. I know what they try to sell me on my side of the street, and I'm like, whoa. So thank you guys for helping fill in the gap so we don't have to worry about that. As always, I want to thank our friends at Penna, XS, Siglant, MechMan, Bird, all my coaxial dynamics elements. These guys, have to have a talk about that someday. It's a different subject for a different day. I called to figure out what the status was on my 25 kW slug for my Bird 43, and boy, it unpacked a bag of worms. So we'll wait and see how this all unfolds. I can't wait to bring you guys up to speed on that if I need to. I think that you guys will find it very entertaining. I will do a video if it's necessary, but them guys are pretty neat. I am trying to float the idea to see if they'll let me come back and sit down with them. I'd like to interview them, talk about the history of coaxial dynamics, and maybe get some video of them and how they set up acritizing, and their, I think it'd be fun. But we'll see. We'll see what happens. Gentlemen, on that note, I'm going to let you be. Thank you guys all for being here. Came here a pile of junk. It's leaving here a winner. Came in here as a working amplifier, but now it's working better. Way better. Like mucho grande better. I think my buddy Mr. L is going to be very happy, so Now all I got to do is put everything back in its packaging and send it the fuck out of the door. Gentlemen, thanks for tuning in. I'm on to the next saga, which I think this afternoon I got to check out a dude's 811H that's here locally, and then I got to move on to RO number 41. Coming soon to a theater near you. On that note, gentlemen, my name is BBI. Without a shadow of a doubt, I'm the biggest mud duck in Idaho by far, in a country mile. Thank you guys for being here. I'll see you. Click, click.